Hi folks, my perspective here. All these paintings have two things in common. They have a horizon line and the trees vertical to that horizon. Now if we add the sun above the horizon, above the trees, that adds an extra element. It helps us understand that the earth is flat and the sun is orbiting our head. So how? So I'm going to show you something that cannot be debunked. It proves beyond a doubt that we're living on a flat earth and the sun is orbiting our heads. We are not living on a spinning ball. So it's the horizon, the vertical trees with the horizon, and the sun above that horizon. So these artists all understood something important. They expressed it in their painting. For them to have painted these paintings, they must have known the earth was flat. So I'm an artist. I've been painting pictures for many years. I know the earth is flat. Everything that I see tells me the earth is flat. So let's have a look at some video footage. That's going to help us understand something important. This video footage, we see the man is using a 360 timer head on his tripod. He sees the sun above the horizon for 24 hours. So as the camera turns, he sees the horizon constantly in front of him. He sees the sun above the trees. At this point, he's facing in the opposite direction from where the sun was rising. Now the sun swings down, back over to the horizon. All the while, he sees the horizon and the sun vertical. He sees the trees vertical to the horizon. It's those three elements. The horizon, the trees vertical to the horizon, and the sun rising above those trees. Right, so he turns around again and he does a 360 rotation. Right, so if we put it into perspective, the sun rises in front of the man. That's at 12 o'clock midnight. At this point, it's 12 o'clock midday. The sun orbits and goes back behind the horizon. 24-hour time lapse of the midnight sun. That's what's happening. He's on a flat surface. The flat horizon, the vertical trees, and the orbit of the sun's path helps us to understand that this is only possible on a flat earth. You cannot debunk this. It's impossible to debunk it. So as the sun gets to this point, he's facing the opposite direction now to where the sun was rising. Immediately the sun swings down. So the sun will arc up and then arc back down to the horizon. The horizon is constant in front of the camera and the trees are always vertical. So if we speed it up, let's have a look, compare it. Horizon, vertical trees, the sun moves up above the trees, now back down again. So at this point he's facing the opposite direction, now he swings back and faces the same direction where the sun was rising. Now if this man was on a ball earth, he has to see the sun behind the horizon, and then when he turns 360 degrees, he has to see the sun behind him, because the sun has to be behind the horizon. So we know that's not possible, right? The man can't turn around and see the sun behind him. He has to face the opposite direction from where the sun was from the beginning of his clip. So let's have a look. What is the man's perspective to the horizon? He always has to keep his camera facing the sun. So at this point, when it's 12 o'clock midnight, the horizon is in that position. He's behind the ball earth. The sun is always in front of the trees. At this position, the sun is above the trees. But what is his frame of reference? The horizon. Do you see the problem? The horizon. He has to see all three. This, in our video clip, he sees all three over 24 hours. The vertical trees, the horizon, and the sun for 24 hours. That's the difference. He has to see this for the 24-hour period. So, if this man is in the northern hemisphere, he faces south. He doesn't move, he just keeps his camera facing the same direction. He can never see the sunrise or the sunset. He's always facing the wrong direction. The sun is always way above his head. So you could say, well, the sun is above the man throughout the 12-hour day period. He cannot see the sun in front of him. You need all three elements, the horizon, the sun, and the trees. The sun has to be vertical with the trees. You see the problem? How does that man facing south see the sun at all? He cannot. He can never paint that picture. He can never take a photograph of the sun above the trees. So it's paying attention to the world that we live in. So in this painting, the artist is facing down. You can see the horizon. The horizon would be higher than your eye level. He has to see the trees vertical with the horizon. But he also needs to see the horizon with the sun. Say, if it's at 12 o'clock, for example, this person cannot see the horizon with its sun above the trees. It's physically impossible. That's going to help you understand. When it's 12 o'clock, or if it's 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, 4 o'clock, and you see the sun in front of you above the trees, you cannot see the horizon in front of you and the sun above that horizon if you're on a board. Just stop and think about it. You can see it at sunrise and at sunset if you turn around and you face in the opposite direction, maybe for an hour, maybe. So let's look at the man's, as the man spins on the ball, what is his line of sight according to the horizon? What is his line of sight? It always has to be 90 degrees to that ball. You cannot see the sun above the trees. It's impossible. So let's do it in 3D. Right, we add a ball to it. We're looking at the top of the ball. The man has to orbit around the North Pole. So for him, he has to turn his camera so that he can keep his camera lined up with the sun. Only as he goes over the curve of the ball can he see the sun in front of the ball, because the ball, Earth, and the sun are on the same ecliptic plane. Now he has to swing his camera around, all the while seeing the horizon and the sun and the trees all in the same frame of reference. Just stop and think about it. If this man was on a ball, he could never ever have taken that video footage. It's simply not possible. His line of sight with the horizon and the sun and the trees don't match. So look at that footage again. If you're on a ball, he has to see the sun above the horizon at 12 o'clock midday and 12 o'clock midnight. Here the sun is above the trees. The trees are pointing upward towards where the sun is. At 12 o'clock, he has to rotate. He rotates on the same parallel as the sun. Now he turns his camera, he has to face the sun. And now his motion is towards the sun. So do you see, this creates another issue. Now if it's 12 o'clock midday, he's in line with the sun. The sun can never rise up above the ball, above the trees. The sun always has to be behind those trees, not above the trees. Because his circle motion is around the Earth's axis, which is a circle. You'll say it's the 23-degree tilt of the Earth, or the 66.6-degree tilt of the Earth. That doesn't resolve this issue. Another issue is his motion is lateral with the spin of the Earth. Now his motion is towards the sun. He has to keep looking at the sun to keep the sun in the middle of his frame of reference. Right, so now, in other words, what would happen to the trees? They cannot turn at the same speed because he's off center. Now his camera at this point has to swing all of a sudden, swing around. So the trees would be moving at different speeds depending on where he is on his borders. Now he's moving away from the sun. So the trees would slow down in their motion. And as he moves across the face of the sun, his speed would pick up again. The same as 12 o'clock midnight and 12 o'clock midday, his speed now would change. So from the perspective of his camera, if he was turning in a circle, what would he see? Trees further away would have to move faster. They would overlap the trees in the front. Trees would rotate in front of the camera. Remember, he's rotating off center. So I've just simply added a camera to the animation. He has to see the ball in front of him. His rotation is in a circle, so he cannot see the ball rise above the earth. He cannot see the ball rise above the horizon. He's rotating in a circle because the sun and the ball earth are on the same ecliptic plane. So what would be rising? The horizon, not the sun. It will be the other way around. But that doesn't change the issue. He has to see the horizon and the trees and the sun above the horizon in the same frame of reference. Speed of trees would change. The trees would have to rotate in front of the camera. His speed, the trees would be moving at different speeds depending where he's on his borders. Right, so you understand the issue. There are many, many issues. So when we look at the video footage, we don't see any of this happening in this video footage. It's a 24-hour time lapse. The horizon, the vertical trees, means the sun is orbiting above this man's head. And if you just look at it, it just is what it is. It's not rocket science. The sun is above the trees, right? It simply means that the earth is flat and the sun is orbiting above the flat earth. The truth is there, just you to look and see it.